Hello, my name is Ashish Kumar, and today I'll be doing a research paper presentation as part of the data mining capstone project. I am going to talk about the paper titled Demographics, Weather, and Online Reviews, a study of restaurant recommendations. This paper was written by Saide Bakshi, Partha Kanuparthi, and Eric Gilbert, and was presented in 23rd International Conference on World Wide Web in New York. During this presentation, I will cover the following topics. What is the objective of this research? What are the data sources and associated attributes? Deep dive into the regression model used for this research paper. I will also analyze the findings, and towards the end, I will offer my critique and will conclude this presentation. Before we go to the objectives of this presentation, I would like to cover few important terms. You'll hear these terms over and over again during the presentation, so I thought it will be a good idea to cover the definition of these terms. Corpus. So, corpus represents essentially a large collection of text data. It is a very standard term in the field of text mining. Endogenous. Endogenous means factors that are derived internally. In our case, in this context of this presentation, a good example would be attributes of a restaurant. Exogenous. Exogenous means something that originates from outside, derived externally. Taking our presentation as an example, it would be something like demographics, geographic location, weather, uh, population density in neighborhoods, etc., etc. Finally, regression. You'll hear me later in the presentation talk about regression model. Regression essentially represents a technique for determining statistical relationship between two or more variables. In essence, we are trying to understand if a change in dependent variable or variables is influencing a change in one or more independent variables. Let's talk about the objective of this research. Online recommendation sites are a valuable source of information for all of us. We all use it in our day to day lives and we also contribute to it. Every time we want to try a new restaurant, the first thing we do is pull up Yelp review and find out what other people are saying about that particular restaurant. Same behavior before we go shopping or we travel. So through this research, research want to understand the following. Given all these exogenous and endogenous factors, what influence do they exert on people's participation in these online communities? And in context of this research, they are focused on restaurant review communities. And if there is an influence, the researchers want to quantify the extent of influence exerted by these factors. As we all know, and confirmed by multiple research, that pleasant weather improves human mood, memory, thinking, and judgment. Uh, Demographics of a region does can also influence the time spent online. So in a long summer days, it's less likely that people will be online compared to dark winter nights where it's likely that people will spend more time online. Based on our knowledge and based on this research, essentially what we are trying to understand is can the factors such as weather, local demographics, can these factors influence the reviews being posted online? Can it lead to increase or decrease in the number of reviews and the rating of those reviews? On the same line, can the racial diversity in a given neighborhood be a factor in terms of, again, number of reviews posted online and the ratings associated with those reviews. Let's talk a moment to talk about why is this research useful. Well, as I said before, online recommendation communities exert significant influence on our daily choices. About two-thirds of people search online reviews before making a decision to purchase a product or a service. Lastly, restaurant industries is specifically influenced by the online reviews. Research shows that an extra half star will result in significant increase in guests, but a negative review by an influencer can have an exactly opposite effect. Now, let's dive into the data model used for this research paper. So, in this model or in this paper, there are two objectives. We want to predict the number of reviews, and we also want to predict the rating of those reviews. To predict the number of reviews, we are using negative binomial regression model, and for ratings of review, we are going to use logistic regression. And there are within each objective. So when we are predicting whether it's number of reviews or ratings of the review, there are two scenarios. One is we run the model just on endogenous variables, so restaurant attributes. And in the second scenario, we are running the model on a combination of restaurant attributes and exogenous attributes like weather, population density, diversity index, you name it. And as you can probably imagine, the number of reviews is a non-negative continuous count. The number of reviews can be 1 and it could go to infinity. Ratings of review usually will be 0 to 10. So for this regression model, you may be wondering why they chose negative binomial regression. So let me take a moment to explain why it makes sense. So when it comes to modeling counts like review counts, we may be tempted to start with Poisson regression. As you may recall from your stats class, a Poisson distribution is parameterized by lambda, which happens to be in both means and variance. While it's convenient to do so, it's not often realistic. Uh, you don't get same mean and variance in your distribution. Definitely the case in the data for this model as well. And that's when you actually go for negative binomial distribution because it is used to describe the probability of occurrence of whole number which will be greater than 0. And unlike the Poisson distribution, the variance and mean are not the same, which is exactly what we need in this case. And the variance of negative binomial distribution is a function of its mean and additional parameter called dispersion parameter. And as the dispersion parameter gets larger and larger, the variance converges to the same value as mean, and negative binomial will turn into Poisson distribution. Uh, so a simple example for negative binomial regression would be let's say a health researcher wants to predict the number of hospital visits by senior citizens in the last year in a given community, and the prediction is based on characteristics of individuals and the type of health plans they're covered by. Finally, chi-square test is used to validate the null hypothesis that each coefficient is 0 or these models are not related, and we'll see in subsequent slides that that null hypothesis is invalidated and models are actually related. So looking at the regression model for count review, we are creating a model to evaluate the impact of endogenous factors. And what you're doing here is we are taking a natural log of y being the number of reviews. I here is intercept right here, and then it's a sum of predictors where your regression coefficient beta right here allows you to understand effect of these variables on the number of reviews. So xi is your component and beta I is actually what defines or what the value tells us whether it has a positive, negative, or no influence on the final findings. And as you can see here, in this case, we are taking a sum of all factors like price, offers, whether it is a bar, delivery, carry out, meal, featured, and then beta is what is the coefficient that is help us figure out the effect of those variables. And when we are taking, in our second case, when we are combining endogenous, exogenous attributes, then you're looking at region, population, income, education, diversity. Note these are the exogenous attributes. And then in addition to, you have the endogenous attributes like price, offers, so on and so forth. And in subsequent slides, we'll also see the actual values of beta, and that will help further comprehend how this makes sense. So you may be wondering, how do you select? I mean, there are so many variables. How do you select the variables that are relevant to the parameter? And to do that, we use a Akaike Information Criteria, AIC, and it is an estimator of relative quality of statistical models for a given data set. And in context of this paper, we are looking to minimize the AIC value, and we pick the variables that leads to minimal AIC. And again, we use chi-square test to find the significance of the regression model. So here is an example. Here are the beta values when we are trying to predict the number of reviews for a restaurant, and on the left hand side you see all the values. You see intercept, and then you see the beta for features, price, bar, carry out, delivery, etc., etc. And below the line are all the exogenous factors, which is like diversity, education, population, region, weather, you name it, it's here. And the way to interpret this chart is, if the value is positive, then this particular factor has positive influence. If the value is negative, then it has a negative influence. And what I want to highlight is comparison of number of reviews that restaurant gets when they're in Midwest compared to when they are in Mountain, Northeast, and Pacific. And I note here that for Mountain, Northeast, and Pacific, the beta values are higher, 0.22, 0.323, 0.60. The way to interpret this is that a restaurant in a Pacific region is likely to receive more reviews than restaurants in the Midwest. And then the fact that value of p chi-square is less than e raised to minus 15 means this is a factor that's relevant for us. Another example would be compared to no offers versus offers. So when there are restaurants, when we compare restaurants with no offers versus the restaurants that offer offers, the factor is 1.69. So restaurant with offers is likely significantly higher number of reviews than the restaurant that makes no offers. And you would also note that, for example, when we're looking at delivery and population in 5,000 to 10,000 density area, even though the factor is 0.31, the p-value is less than e minus 5, means this factor didn't matter as much, even though it has a positive attribute. Uh, and the way to interpret these results is that you have ed model, which is for endogenous, and ed plus x is endogenous and exogenous. And the fact that the value of chi square is less than 2 e raised to power minus 5, it's actually raised to power minus 15. It means that our null hypothesis is invalid, and indeed these values, these two models are related. And you can certainly find more detailed explanation of this in the paper itself. Continuing on, so let's talk about how the model used for predicting the review ratings. And rating is on a scale of 1 to 10. And in this case, same idea. We got two different paths, one for endogenous, another one for endogenous and exogenous. We are going to use logistic regression, and as you can see in the chart here, we are looking, beta is again the coefficient that allows us to understand the effect of independent variables on the ratings. And then we are going to use independent values to set of independent values to minimize AIC. For reference, snow and precipitation values are log transformed. And in this case, yi is actually the right here. Yi is the ordinal response variables that can fall in categories of 1 to j, and then pij denotes the pi ij denotes the probability of observation I falling in category J, and gamma ij represents the cumulative probabilities. Again, looking at the same way to interpret this chart, and I'm going to highlight two things here. When the temperatures are in the range of 2200, your restaurants are likely to receive positive rating. And the fact that the values are less than e raised to power minus 5 means these values are strongly correlated. But when temperatures go above 100 degrees, then ratings are likely to dip. Similarly, and there is a very detailed explanation of this in the research paper as well, when restaurants have higher priced, when they're rated in $4, for example, they're likely to receive higher rating when compared to just medium price restaurants, which is receives positive rating, but you can see that the number of positive ratings actually starts to decline as restaurants starts to become cheaper and cheaper. And here, just like in the previous one, degree of freedom actually represents the number of predictors, and low value of PR means chi square rejects the hypothesis. Model with exogenous variables is significant. Now let's dig deeper into the findings of the paper. Let's start with endogenous attributes and its effect. Just a reminder, endogenous attributes are internally driven, so they are more tied to restaurant attributes. Higher priced restaurants are more likely to be reviewed by online users, and they're also likely to receive higher ratings from those users. And as explained in the paper, it is because the customers are there to experience the ambience and the decor as much as they are there to experience good quality food. When restaurants have special features like bars, it leads to higher number of reviews, but a decline in rating. Restaurants that offer delivery service more often than not experience positive effect on the number of reviews, which means they see more number of reviews, while restaurants that offer carry out but offer poor experience will see a decline in number of reviews. Delivery service itself does not lead to increase in positive ratings, but when customer experience poor experience in terms of carry out, they will most certainly give negative ratings to the restaurant. Promotions in general have a positive effect both in terms of number of reviews and ratings for a restaurant. No wonder we see so many promotions from restaurants. Moving on to exogenous factors. When restaurants are in the regions with population density between 1,000 and 2,500, they receive largest number of reviews. If the restaurants happen to be in the areas of higher or lower density, it leads to fewer reviews. At the same time, the effect of population on the rating itself is negligible. Local population density and availability of delivery service have higher chance of being reviewed. In other words, when the delivery service is combined with the population density, medium size, it improves the chance of being reviewed. When a restaurant offers a carry-out service in a highly dense area, where density is greater than 10,000, it will also lead to higher rating than in other regions. Restaurants in a certain geographic regions are likely to receive more reviews. When researchers ran their regression model, it showed that restaurants in Northwest are likely to receive more reviews when compared to restaurants in the Midwest. And but ratings remains uninfluenced by the geographic regions. So neighborhoods with higher percentage of college degrees, again, in those neighborhoods, restaurants are likely to receive more reviews, but it does not translate into better or worse ratings. Rating is not influenced by the education level. A neighborhood with medium diversity will also lead to higher online reviews, and yet again, rating is not influenced by the diversity. So one of the common theme is that none of these demographics or population or geographic regions are having any impact on the rating itself. I mean, we saw it in this slide, we saw it in the previous slide. While it may lead to more reviews, the rating itself is not directly tied to much of these exogenous factors. Moving on, one thing that does influence and impact the ratings is the weather and in turn the day and the time of the year. For example, number of reviews will increase in summer month and decrease in winter months. At the same time, ratings will decline in summer months and tend to be higher in, let's say, November. When it rains or snows, restaurants can in general expect an uptick in negative ratings. But when the weather is fine, when it's between 70 and 100 degrees, restaurants can expect better, higher ratings from the users. And just because the weather conditions are attributed to conditions at the time of review, the data and research, the data did not provide any insight to researchers in terms of if it had any weather conditions had any influence on increase or decrease in number of reviews, which does make sense. There is no doubt that this is a great research paper with a lot of valuable information. However, I do feel that there were a couple of areas where it fell short. Uh, I I think that this paper fails to substantially back the claim that exogenous factor exert a significant effect on recommendation. These factors may contribute to higher number of reviews, but except temperature. There was no other factor that had any measurable impact on the ratings of those reviews. Uh, Also, the paper did not explain the causality between these factors, whether it's exogenous or endogenous or a combination thereof. On a positive side, the paper, the best part of the paper is the part where the researcher explained the influence of pricing brackets on the number of reviews and the ratings received by the restaurants. I think that piece is the best part of this paper. To conclude, the paper presented a good regression model, which can be extended to other areas such as shopping or hotels or travel. The work presented in this paper can be extended to quantify factors such as popularity. For instance, is a restaurant with 1,000 reviews of 3.5 star rating in New York City more popular or less popular than a restaurant with same number of reviews but higher average star rating in Cleveland, Ohio? I think it's a great research area, and if we can come up with a quantifiable way to measure popularity, everyone will benefit. That concludes today's presentation. I hope you liked it. If you have any question, comment, or suggestions, please feel free to contact me at the email address listed here. Thank you.